Hi, welcome to Data Engineering. Today we are going to discuss about an end-to-end project in Spark Streaming, which includes Kafka, Spark Streaming, and Cassandra, the NoSQL database. So this is going to be like a project. So please watch this video completely. If you skip it, like you will not understand in between. So please watch the video completely. Yeah, let's get into the topic. So first, let me explain you what I'm going to do in theory, and then let's move into practical. Okay. So imagine I have an application. Okay, so I have a application, a e-commerce application where people are trying to purchase a product by clicking the product image or product button. So back end, what I'm actually going to do is I'm going to do some kind of an sentimental analysis, and that is an end goal. So here I'm going to capture the click events of the user, and then I will understand what I will try to understand what they are trying to visit in what page, what product, and if they are not doing the purchase, I have to understand why they are not doing it, even though they are clicking that particular product these many times in a day, but still they are not purchasing the product. So I have to identify that. So for that, I have to first gather the data and I have to store it somewhere, and that is what I'm going to do today. So I'm going to capture the click event through Kafka, and then it goes to Spark Streaming, and the process will happen over there, and then finally it gets stored in Cassandra, and from Cassandra the reporting team, someone or some other reporting team can get the data, and they can understand what is happening over there. Okay, so let's imagine we have an application, and I'm going to use the Kafka, which is a data pipeline tool for streaming data. And this is not data processing. People used to sometimes say Kafka is a streaming data processing tool. It's not a processing tool. It's a real-time data retrieval or stream data retrieval. That is a data pipeline. So from Kafka, it goes to Spark, and which is Spark streaming, and then it goes to Cassandra. So this is a high level overview of the project what we are going to do today. So let me get into some technical aspects, or somewhat like second level of information I'm going to give now. So if you take Kafka, there is two things in Kafka. Kafka splits into two, which is Kafka producer and Kafka consumer. Kafka producer is where the data that get produced, and Kafka consumer is where we consume the data. So here the Kafka producer, it has this for Kafka producer there is a Java code, and then for Kafka consumer also there is a Java code, Scala code, Python code is also there. Imagine it's a Java code. So what you have to do, imagine there is a product image here, and there is a button. People are trying to click this button where they want to see the product, what it is, and all those stuff. Now I have to write this Kafka producer code. I have to integrate to this web application back to this button, back end of this button click code. Okay, so that means when the user click this button, it captures all the user events, and that goes to Kafka producer. Means when I say Kafka producer, it produces the data. Now here the Kafka consumer will consume the data whatever the Kafka has been produced. So now Kafka consumer is something that I'm going to write inside Spark streaming. Okay, so this is not batch. Okay, let me write it as Spark streaming. So that means within Spark streaming, the first line is to connect Kafka, and then I'm going to get the data from Kafka, and then I'm going to create a Spark streaming, and then finally I'm going to write it to Cassandra. So this is what Spark streaming code will have, which also has the Kafka consumer. So that means this is Kafka producer, and this is going to be the Kafka consumer. So for with respect to Kafka, it's a messaging queue tool. So if you want to have a brief understanding of Kafka for some extent, there is a video that I have already uploaded. I'm sharing all the prerequisite videos for this particular end-to-end project video. I'm sharing all those video links in the description box of the video. For example, if you want to do this project, you have to install Kafka, install Spark, install Cassandra. So there is a 3 separate video for that. You can have a look, and then you can do a setup. And then to understand what is Kafka, there is already a video, and for Cassandra also there is already a video. So for Cassandra, if you don't see the link, please wait. Within a week I'll upload all the basic Cassandra video series, and if the link is already there, please have a look on those videos as well. Fine. So now like this is what I wanted to tell you. This is what actually we are going to do. So this exercise, this project is even asked in interviews, especially when it comes to Spark streaming or even the Storm streaming. Okay, there is an alternate technology stack for Spark streaming, which is Storm, right? So even in some interviews, they're asking, give me an end-to-end Spark streaming, like from Kafka to streaming to Cassandra, and they are also giving 1 week of time to do this exercise. Whatever I'm going to show you for next 20 to 30 minutes, the same thing they are giving a time of 1 week to do, right? So and also this helps you in the interview as well with respect to Spark streaming, and also this is actually an end-to-end project which will help you to build a bigger level of project based on this video. Fine. So let me explain you the process, what are all the tech stack and process we are going to do the installation, right? So let me explain you that. So we need Kafka. Okay, so Kafka is the first tech stack, and then we need to set up Spark, and then I need to set up Cassandra. Okay, so what are all the services which is going to run for Kafka, which is Zookeeper. So Zookeeper is a daemon that runs for starting Kafka. You need Zookeeper, which runs in the daemon name of core peer main, and then you need to start Kafka daemon. So these are the two process which we need in Kafka. For Spark, which is already like we are aware of, right? Master and worker, so two daemons. And I'm going to show you the program, the code, the Spark streaming code in Spark shell. You can the same code you can write it in a project, like by using IntelliJ or Eclipse. You can build a Java project, and then or it's a Scala code. Actually, you can build a Scala project, and then you can build a jar file, and then you can run it via Spark submit also. But to make it simple, I'm doing it in Spark shell. So even you do this in Spark shell, there will be a process running in background which is Spark submit. So three process. And for Cassandra, there will be a process Cassandra daemon which will be running. And today I'm going to show you this exercise with a web application as a front end. So I need a web application process as well. So I'm using a server called Tomcat, which is a server, a service, web server, which I'm going to run, and the daemon process for this is Bootstrap. So this is highly optional. So don't consider this as a mandatory one. Just for you, for the video purpose, I'm to make it more realistic. I created a web UI using a web language called JSP, Java Server Page. So this is highly optional. So you can ask me if there is no front end application like this, how can I test this application end to end? I will tell you the alternate way to test this application as well. Okay, I will tell you that as well. So that means, so in my mission, I'm going to have all these process running. So make sure that much amount of RAM you are having it available in your mission. So here the environment, I'm going to use AWS, which is cloud. In cloud, I created a virtual machine. We call it as EC2. That is the name of virtual machine people use in AWS. And this is also highly optional. If you don't have any cloud, I don't have GCP or AWS cloud, completely fine. Leave it. So you have already your laptop. In laptop, you already have a Ubuntu or some other Linux, and you already have all the setup. Or like it's a new Linux laptop, but you need to do all the setup. That's completely fine. Do it in your laptop itself. Given condition, if you have at least 4 to 6 GB of RAM, that will be fine. So since I do all the exercise in my cloud missions only, and that's why I'm using AWS here, but this is completely optional. Don't get confused. Okay. So here I created a virtual machine. In AWS, we call it as EC2, Elastic Compute Cloud. I created a mission. So in that mission, I installed all this Kafka, Spark, Cassandra, and I've started all the process. And then I'm going to show you the code by running it in the Spark shell in the virtual machine. Fine. So this is also done. Now let me get into the practical thing. So I'll just open my AWS. So this is my cloud console. So don't get confused again. So I just have my one virtual machine which is running, which has a public IP address. So this is an IP address which I have to use to log into my virtual machine. So these steps you can ignore if you are using the complete whatever I'm going to show you today, which you are going to use it in your local machine. You can completely ignore this. Okay, so authentication. So there is no password in AWS, like instead we used to have the key file. So let me open my mission. Okay, so the username for my virtual machine is Ubuntu. So let me open it. Let me increase the font size. So I will just go with 14. Yeah. So I hope it's much better now. So if you see here, so I have all the tar files and then I have untarred it. So as I told you, the installation videos, all a separate video I have already uploaded. Please go through that video and do a setup. Like you need Kafka, Spark, and Cassandra needs to be get installed already before starting this exercise. Fine. So first what we can do, let me get into Spark, and then I will start the daemons. So sbin slash start h1 all dot sh. So that's a command to start your Spark daemon. So when you start it, you will have master and then worker. So let me test it by giving JPS. Yeah, it's there. Now what is the next thing we have to do? Let's start Kafka. Okay. So I'm going to share you the steps along with the code in my blog. So that blog URL also will be in the description box. You can have a look. So this is the version of the Cassandra, Kafka, and Spark which I'm going to use. Sometimes if you change the version of this, like change the version between this components, right? So the connectivity will not work. So make sure that you are using the same thing. So to start Kafka, first you need to start Zookeeper. So let me copy this. Command is to start your Zookeeper. Zookeeper acts as a metadata service for Kafka. So let me run this command in the background. So the service will be running in background so that I don't want to open multiple terminals. So I'm using the NoHub. This is a Linux command to run any foreground process in background. Okay, so no hub, and then I'm going to write all the logs. What is going to means what it is going to get print with this command, right? So I'll have the log name as no hub out, and then ampersand symbol. Yeah. So now if you give JPS, you will see a daemon called quorum peer main, which is zookeeper daemon. Next, you have to start Kafka. Start Kafka. So no hub, and then no hub dot out, and then ampersand symbol, right? So this will start Kafka. Okay, so you can see the Kafka daemon is started. So now we have started Kafka also. So what is next? So you have to start Cassandra, right? So Cassandra, there is no very big installation step with respect to Cassandra. So all you need to do is just untar the Cassandra file after downloading, and then you just run this command, and that's what. So there is no installation in Cassandra actually. If it is required, yeah, there is few steps to do, but as a fresher, like you are doing a Cassandra stuff, right? So just to start with the practical, there is no big steps to do. Untar it and start the Cassandra service. That's it. So this is a service which we are going to start now. So no hub, and then the service, and I'm going to run this in background. So for Cassandra, you will not see the daemon name in the JPS, which will be running in background. To check whether Cassandra is working or not, you can log into Cassandra shell. So we have this Hive shell, Spark shell, MySQL shell, Oracle shell. So similar to that, for Cassandra also we have the shell. So if it is entering into the shell, it is working. Okay, so we call all the shell as REPL. Even Hive has a REPL, Pig has a REPL, and then like Cassandra is also having REPL. So we do all the Cassandra DML, DDL commands, the select, insert, delete, everything under this shell only. So Cassandra is running. So for just for checking, I've just entered into it. So for our exercise, we are going to capture the click event, and then we are going to process in Spark streaming, and then finally we are going to store it in Cassandra, right? So for that we have to create a table and database with some column names, right? So let's go for it. So in Cassandra, we used to call the databases as key spaces, and this is a command to create the key space. So the key space name is Spark data, and the replication is simple strategy, and replication factor is 1. I have explained all this in my Cassandra video. You can have a look on it. And then so let me create this, but before doing it, let me drop. So I have already created it, so let me drop the key space Spark data. Okay, it's not there, it seems. Okay, so let me, okay, so I'm sorry, I gave a wrong command. So drop key space and then Spark data. Yep. Okay, so yeah, it's dropped. So now I'm going to create a key space which is called a database, right? So which is equivalent to creating a database, and then use Spark data. Like it's similar to MySQL. So once you and Hive, in Hive also we do this use, right? And then you create a table. So create table, table name. Table name is custody data, F name, L name, which is last name, URL, and then count, and then the product. So these are all the information which I'm going to capture from the user, right? And you can able to see something called counter. So counter is actually a data type in Cassandra, and you can also see in primary key I have given all these. So I will give you a very quick information about what is this counter and primary key, why you have given all the 4 columns in primary key at last. I will tell you why I'm doing this. So first let me create. Now I'll do a select star from cast data. Okay, so it's empty, right? Fine. So why f name is in red color and count is in some pink color, right? So it's all like we need to understand the basic things about Cassandra. So as I already told you, like there is a video, you can have a look on it. So you will understand all this information over there. So let me come out from Cassandra shell. So let me do a JPS and see whether all the daemons are running. Yeah, so I have the Kafka daemon, Spark daemon, Cassandra is also running. So next, what else I need is I need the Tomcat web server to deploy my web application. Okay, so how we used to generate a jar file in Java and Scala, right? So similar to that in JSP. JSP means Java server page. It's a web programming language, server-side programming language where people used to write program to develop a web application. So they used to archive that as a var file, web archive, like jar file. In web application they used to say var file. So you have to deploy that var file in this web server, and then only like you will able to see the web application UI in the browser. Okay, so let me start. So I have already placed the server, means the var file. So you don't want to get confused about all this information. So this is completely optional for you. You don't want to do at all. I will tell you what is the alternate way to test the end-to-end application. Okay, I'll tell you that. Don't worry. Okay, so it's running. So let me show you my web application as well. Okay, so this is the URL. Let me. Oh, sorry. So for every restart when I do my AWS mission, right? So the IP address will get changed. So that's why it's not loading actually. So let me change my IP address. If it is your local, then you have to give localhost here. Yeah, so this is my web page. Okay, so this is a web page which I created. So whenever the user feed all the information and then they choose the product, and when they click the product, like by giving a OK, so the events will be captured. Okay, now what I'm going to do, I'm going to enter into my Spark shell. Okay, so let me go back to my notepad. So here you have to start your Spark shell with these two packages. So the first package is to connect Spark with Cassandra, and the second package is to connect Spark with Kafka. So you can give hyphen packages and this package name automatically. This the jar file, the dependency will be get downloaded from the internet for every time you have to do this. Okay, it's not like a hard setting; it's like soft setting. So you have to do this every time. It's not permanent. So I will tell you one. Warning as well. So this hyphen packages will not work if you are doing the same exercise in your company laptop or company server machine. Okay, so this will not work. They will restrict it. So for that, what you can do, you can manually download these two jar files from the Maven site, and then you can place the jar file somewhere in the machine, and you can use hyphen jars instead of hyphen packages with comma separated. Then this will work. Okay, so I'm doing it with hyphen package because this is my own environment, right? So it will work. Enter. Okay, so once we enter into the Spark shell, let's try to give all the imports, the necessary imports, whatever it's required, I have to give. So when you enter into the Spark shell, right, by default, the Spark context, the session will be get created in the name of Spark. So you have to stop this because we are creating one more session for Spark streaming. So you cannot have more than one session created in the Spark shell. Okay, I will tell you. I will show you that error. So first imports are done, and the next line I'm creating an app name. I'm creating a Spark conf, and then I'm setting an app name, and then I'm setting properties to connect Cassandra, the IP address on which my Cassandra instance is running. Okay, so that is done. And the next command is I'm creating a streaming context with the Spark configuration. And for each and every message that comes from the Kafka, right, the time interval which I'm giving is 20 seconds. So you can increase and decrease by increasing and decreasing the value here. So I'm creating a context here. So if you run this, right, you will get an error. You can see only one Spark context may be running in this JVM. So you have to stop the Spark session which is already running. So that is in the name of Spark, right? I showed you here. Okay, you can see here. So it's available. Spark session is available as Spark. So let me stop this. Okay, now you can run the previous command. See, it is working. Right, fine. So next you have to mention the Kafka topic. Okay, so I'll tell you what is that. Let's go top. See, we started Zookeeper and then we started the Kafka service as well, and then you have to create a topic. So in Kafka, the producer and consumer will work only to a specific topic in common. So that is something required. In Hadoop, we have Flume, which is an alternate for Kafka, but in Flume, there is no concept of topic, but here there is a concept of topic. So we create multiple topics, and each topic will work with the Spark consumer and producer. Okay, so this topic we are supposed to create. So what I will do, I will open a new window. I will open a new window and then I will change my directory to Kafka, and then I will run this command. So you will see like topic created. So if you want to list the topic, there is another command that connects with Zookeeper. Zookeeper is a metadata for Kafka. It connects and brings the topic list. So I have only one topic you can able to see here. Okay, so we have created the topic, right? So let me close this window. So now you created the topic. So this topic is what you have to mention here. So we have to convert this topic into a map. So we are doing it here with the number of threads, like what number of threads in which the topic has to run. So for the parallelism, so I'm giving one and then I'm converting it to int, and finally I'm converting this to map, and in the variable it gets stored as topic map. So this is for mentioning the Kafka topic name. Next, you are creating a Kafka util.create stream. This is for enabling the streaming between Spark and Kafka. Okay, so val line Kafka utils.create stream SSC is the streaming context that you have created. Localhost 2181 is the Zookeeper host and port number, because Kafka needs to know the topic and other information from the Zookeeper because it has the metadata information. So Spark group, you can give any name here. It's a group name for this job, and then topic map is actually your topic. Okay, so I'll just run this command. So I've just feeded all the information. Okay, I didn't run this. Okay, first I will run this and then I will run this command. Yeah, okay, it's working now. So next, you can, if you want, you can print and see. And what is the line number 68? This is a line for connecting Cassandra from Spark. So lines.map, for each line, I'm saying the data that comes from Kafka from the front end is comma separated. And then I'm for each column, I'm mentioning as array of 0, 1, 2, 3, 4. And then save to Cassandra is a command that comes with the Spark Cassandra API along with this data stacks package. Okay, so here you have to give the key space name. So what is the key space name here that we created, which is actually the database name, and then custody data, which is actually the table name, and then some column is actually a keyword inside which you have to pass the list of column names. So now I'm going to run this. Okay, so now a connectivity for Cassandra to Spark has been created. Now what is next? I have to start the streaming actually. So ssc.start, which will actually start the streaming now. So now what is the next step I have to do? I have to open a new window. So the data, what I'm going to populate, where I'm going to populate with the web application. Finally, where the data goes to Cassandra. So now I have to log into my Cassandra SQL shell. Apache, let me increase the screen. Cassandra bin slash SQL sh. So the key space name is Spark data, and then select star from cust data. Okay, so now let me go to my web application which I have created. So what I will do here, I will go and say like Gautam. Okay, it's already there. Last name SB, and this particular user is actually showing interest on the mobile. So when I click OK, so what JSP application it will do, so it will capture. So inside JSP application only, I have written my Kafka producer code, the Java code, which will actually retrieve this web URL from which URL I'm actually watching the products, and then the last name, first name, and then the products and everything. So let me click OK. So I have also printed a custom message here. Data has been produced. Please check the Kafka console consumer. That means you can check in the consumer as well, or you can check in the Cassandra. So select star from C. The data has been populated here. I will also show you the Spark shell window. See, you can see some logs has been printed here because the data has been populated, which comes to via Kafka. It comes to Spark streaming. In Spark streaming, we have written a consumer of Kafka, which will receive, and then it stores to Spark. That means it stores to finally to Cassandra. Okay, now I will tell you like how can like I can how I will believe the data that what you have given the web application only comes to Spark. So we have to cross check that as well, right? So what I will do, I will open another window. I will show you the data how it comes to Kafka. Okay, so let me get into Kafka consumer. So there is two more process. If you see here in Kafka, there is something called console consumer and console producer. This is completely for testing purpose. So you can use the Kafka console consumer to check whether the data has been consumed by Kafka or not. Imagine some data has to come from Kafka to Spark, but finally the Spark has not given the data as an output. So now here the problem, I need to know whether the data was not consumed by Spark or Kafka. You need to know, right? So now with the console consumer, you can check whether the data comes to Kafka or not. If it comes to Kafka, then the problem is with Spark. So now this is the command, consumer command. I'm giving consumer.sh zookeeper port and IP address, and then which topic it is, and from beginning is it will retrieve the messages from the beginning of the topic got created and the data got populated, right? So now I'll run this consumer here. Now see, the first message what I've sent through the web UI has been come here. So now let me show you the web UI here. So what I'll do, I'll go with some name. Okay, Saravana, and then P, and he is watching some product of fashion. So okay, so when I click OK, see it comes to consumer. That means Kafka is working perfectly. So this is where I have written my Kafka producer as a JSP application. This comes to Kafka consumer. That means it comes to consumer. Kafka means Kafka is working fine. So automatically the data has to go to Kafka. Sorry, Spark. Automatically the data has to go to Spark. So let's check the output in Cassandra. See, the data has come to Cassandra as well. So that means end to end it is working fine. So now I will tell you how to do without web application. Okay, so imagine there is no web application now. So let me open one more window. So you can populate the data for Kafka via Kafka producer. So the console producer. So there is a one more command. So you can test the end-to-end application with this command. So you don't want to go with web application or something like that. So just go with Kafka console producer. This is for generating the data for your application. So this is your consumer, right? So let me minimize the screen. See, whatever I'll give in the producer, it comes to consumer. You can see both the terminal. Please listen both the terminal. So I'll go with the name Rahul, comma K, comma some address HTTP and some number I will give as IP address, and that's all. So comma, the product is like dress, and then I'll give the number of count he visited. Okay, so I'll give one. So default is always one. Okay, enter. So now this will come here. See, in left hand side, consumer, it comes to consumer. That means you don't need a web application. You can directly test with the producer. I created a web application only for the video purpose, just to give you a feel of having it as a real time. So let me go back to Cassandra and see whether the data has inserted or not. See, the Rahul data has been inserted. So now I showed you end to end, but I want to tell you one more thing with respect to the Cassandra table. So the sentimental analysis, what I'm trying to do here is how many times a particular user is visiting a website. I want to increase the count. For example, Gautam from the same IP address, he is watching the same product for 3 times in a day. That means I have to capture the count 3. So now the reporting team has to do more process on top of it. Like 3 times the user is watching the product, but why he is not purchasing it? So I have to identify. Okay, let me try to give some offer only for that particular user. I will give some kind of an offers or discounts to him, because when you watch something products in the Amazon or Flipkart and you are not purchasing it, immediately you will get all the advertisements and all the pages whatever you are doing visiting, right? So this is how internally they capture the data and do this. So now what I will do, I will show you. So the counter data type, what it actually do is, whenever the value of each column comes as the same value, then this count will get increased. And that is the reason we are giving all the column name except the counter column name in the primary key field. So this is a rule in Cassandra. When you use this counter data type, the non-counter columns, that is fname, lname, URL, product. So these non-counter column should come under primary key. So that is a rule in Cassandra. And you may ask me one more question. Primary key means it won't allow duplicate, right? But in Cassandra, primary key means it's different concept. So primary key in Cassandra will allow you duplicate. That means it will do an upsert. Okay, so for this you need to see all the Cassandra videos as I suggested already. So now what I'm going to do, I'm going to explain you the actual counter use case now. Let me use my web application. So I will try to give the same information, Gautam. Okay, let me give the same name, Gautam, same last name, SB, and product same mobile. Okay, so now Gautam SB is just showing the interest on mobile second time in a day. Okay, give OK. Now I'll come here. So now the data goes to Kafka to Spark, and finally it comes to Cassandra. Now you can see the count will be get increased here. Let's wait for 20 seconds. Yeah, so you can see the count got increased. That means the same user from the same URL, he visited 2 times. You can see here in the Kafka console producer, this one is actually default. Always you have to give one only, because we don't know how we will increase. So it should be always one. Now I will show you in producer window also. Let me copy the same, enter. So now I will show you through producer, console producer also. Now here if you see the Rahul K, this IP, this product dress will be get increased to one more count. Let's wait for 20 seconds. Either you do it in web application or you do it in console producer, both are same. Okay, so anyway it is same. So you can see here too, because sometimes people used to ask me why you are giving this one. Do I need to change this one? No, we don't want to change this one. So this is a hard-coded value. So always you give one only, that is completely fine, because every time the user visit, it's one occurrence, but the counter will take care of incrementing this value. Okay, so now imagine a new value comes. So that will be a new record actually. So I'll do this. So I have a record as Bharat. Some value D, and again fashion. Okay, so now this will come as a new record, because there is no record already with the L name, last name, first name, and URL matches to this value what I have given now. See, it entered as a new value here. Right, so now again Bharat visit from the same website with the same product, the count will get increased. So this is what the sentimental analysis we are trying to do with the counter option available in the Cassandra. Okay, so I hope you enjoyed this video. So this complete video, I hope it's helped you really. So as I already told you, this is actually a project, and some companies give some 2 to 3 days or sometime 1 week of time to do the setup, and they will ask you to give a walkthrough on this in the interviews. I'm saying they will give some time to do this. So this is what something is actually a project. You can articulate this, you can even add this in your resume, and in upcoming video I'll explain the problems that we face in this particular project. Like sometime Kafka, the data will be get consumed, but in Spark it won't come, so we have to debug, and those problems, the messaging semantics is what we used to call it as a problem. So we'll explain you all those in the upcoming videos, and if you really like this video, please do subscribe my channel and forward this to your friends and colleagues. So thanks for watching, and if you want to have visit the complete big data video, the in the description box I have given the playlist link called big data course, in which you will see all the big data related videos, and also I have shared all the links, prerequisite links what you have to see before watching this video. That also I have given in the description box, including the code and the steps, everything I have written in the blog, and that blog URL also I have given in the description box. Thanks for watching. Have a nice day.